Hello, in this video I'm going to be going over how to draw valence electrons correctly around each element. And this of course depends on how many valence electrons that element has. And we have to again make sure that we draw them in the correct order. This is going to help us determine how many lone pairs of electrons that element has. So by lone pairs, a pair of electrons that will not be participating in bonding. And then it will also tell us how many electrons will be by themselves, and those electrons will participate in bonding. One thing that I do want to point out is on your periodic table, the numbers that you see, not the charges, but the numbers above each group on the periodic table that I'm circling, those are the numbers of valence electrons for each group. So group 1 has, over here, has 2 valence electrons. Group 2 has 2 valence electrons. Group 13 has 3 valence electrons, and so on and so forth. Don't worry about these groups here. Those are not our concern. So we're going to have to be referring to our periodic table to figure out how many valence electrons each element has based on the group that it is in. Okay, so let's get started. So with the first one, I'm just going to start here with hydrogen. So hydrogen is in group 1, so it is only going to have 1 valence electron. So since it only has 1 valence electron, technically we can draw that on any side that we wish to draw it on. I'm just going to draw it right here. Okay, once we get a little bit farther, it's going to matter where we draw the electrons. So hydrogen is an element that we're going to see in covalent molecules, and hydrogen is one of those exceptions to the octet rule. It will only be surrounded by a max of 2 valence electrons. And since hydrogen only has 1 valence electron to share, it will always form 1 bond. So oftentimes when we're doing covalent Lewis dot structures, covalent molecules, we're drawing their Lewis dot structures, hydrogen will always just form 1 bond. So it's often going to be drawn like this in a final Lewis dot structure. Lithium, this is a metal, so it will form a ionic compound, and lithium is also in group 1, so it will also have 1 valence electron. When we get to ionic compounds and drawing their Lewis dot structures, it is different from something like this where like the electrons are being shared and we're showing those bonds like this, because in ionic compounds the electrons are being transferred. So we will get to that when we talk about ionic compounds and their Lewis dot structures. We're going to talk about how these electrons get transferred. Next, we have Be, which is beryllium. I'm just going to refer to my periodic table here. So again, hydrogen and lithium were both in group 1, so they just had 1 valence electron. Beryllium is in group 2. It has 2 valence electrons. So again, when we draw these, we have to make sure that we draw one on each side before we start pairing them up. So for beryllium, it has 2 valence electrons, so this would be technically the correct way to draw it. You would not draw it like this. That would be incorrect. Beryllium is also a metal, so it will form an ionic compound. And again, that has to do with a transfer of electrons. So we won't see it forming really bonds like this because it is an ionic compound. Next, now we're going to start getting into the elements that are non-metals, which are pretty much all of these guys over here to the right of that staircase. And these will form covalent bonds. So boron, which is right here, is in group 3. This is also another exception to the octet rule. So it has 3 valence electrons. So again, we have to draw it in this order. So we have to do 1, 2, and 3. Okay. Does it have to be like this? No. You could have drawn it like this, or you could have drawn it like this. The key thing is that you put an electron on each side before you start pairing them up. And boron is actually another exception to the octet rule. It will actually only form 3 bonds, so it can actually only be surrounded by a maximum of 6 valence electrons. And boron would be a nonmetal, so it would form a covalent molecule. Next, we have carbon. It is in group 14, so it would have 4 valence electrons. So again, I have to draw 1 on each side before I start pairing them up. And we'll see that with our next example here with the pairing up that I keep talking about. So this is how I would draw carbon. Carbon, I'm not sure if you remember this from biology. Carbon is the building block of life. It has 4 valence electrons. It can form 4 bonds. These bonds can also be represented in a different variety of ways, which we'll get to when we start drawing more Lewis dot structures for covalent molecules. But carbon, it's a nonmetal. It will form covalent bonds. Next, we have nitrogens. This is where we're going to start seeing those lone pairs, and we're going to start seeing this rule that I've been talking about take place. So nitrogen is in group 15, so it has 5 valence electrons. So when I draw those, again, I have to do 1 on each side before pairing them up. So I would do 1, 2, 3, 4, and now I can start pairing them up, okay? Do you always have to start on this side? No. I could have done this too. I could have done 1, 2, 3, 4, 5. The key thing is to draw 1 on each side before we start pairing them up. So this right here is what we call a lone pair. So nitrogen is a nonmetal, so it will form a covalent molecule, covalent bond. So those lone pairs, that just means that those electrons won't participate in bonding. So nitrogen will always form 3 bonds, and it will have 1 lone pair. Again, it could be drawn like this, or it could be drawn like this. And I didn't show you this with carbon, but you could also even draw it like this. Okay. Again, when we get to covalent bonding, covalent molecule, Lewis dot structures, this will make a little bit more sense. For now, I'm just going to leave it like this. Next, we have oxygen. Oxygen is in group 16, and it has 6 valence electrons. So again, it doesn't matter what side I start on, but I just have to make sure that I draw 1 on each side before I start pairing them up. So let's do that. So 1, 2, 3, 4, 5, and 6. So oxygen, you'll notice it has 2 lone pairs. So those lone pairs would not participate in bonding. So oxygen can form 2 bonds, and it will have 2 lone pairs. And our last one is fluorine. This is in group 17. It has 7 valence electrons. So I'm going to head and start on this side. So 1, 2, 3, 4, 5, 6, 7. So fluorine will have 3 lone pairs, and it can actually only form 1 bond. Now, I know that, I've been talking about this a lot. Do not feel like you have to memorize this when it comes to drawing Lewis dot structures for covalent molecules, because ultimately you have to arrange the valence electrons correctly so that each element is surrounded by 8 valence electrons. Knowing this can be very helpful and make drawing Lewis dot structures easier, but again, don't feel like it's something that you have to memorize. So these guys here that I was talking about, these are all non-metals, okay? So all of these will be covalent, okay, in nature because they are non-metals. These two right here, these will be participating in forming ionic bonds because they are metals. So again, with covalent bonds, we'll see a sharing of electrons with these various bonds that form. And with the ionic compounds, we're going to see a transfer of those electrons.